Thank you, Andrzej. Hi, guys. It's a great pleasure and honor having so many of us at the speech. High five for those of you who are online. As Andrzej said, I work for Allegro as a part of a data platform engineers team. Our location of our team is in Toruń, so big hug for you guys who are watching me here. And I would feel much comfortable to talk to you about bicycle trips, but you came here for some technical stuff, so let's go. Main responsible for our team is maintaining and supporting big data platform and all the tool set for data engineers and data analytics. For some time, we are flying to the cloud, and I would like to tell you some. I would like to put some light how we do it, and about what we struggle. So main areas of the presentation cover our clients of our team who know what to do. They are brilliant in their business tasks. They are data analysts, they are data scientists, and they don't need to care what is under the hood, their calculations, their workflows. They want to get feasible, simple environment for running the jobs. We also have another guys. They not only know what needs to be done, but they also know how to do it. They are developers, they are data engineers. They need much more freedom in their work lifetime. So we somehow have to deal with such two worlds. We will be going through our on-premise big data stack, which we migrating to Google Cloud platform. So we use well-known technologies for data mining. We use Jupyter. When your job developed in Jupyter is ready, you want to schedule it and run in production environment, so you use Apache Airflow for that. And processing power is given by Apache Spark cluster. So when we migrating to the cloud, we are looking for similar technologies. So we also in GCP use AI notebooks from Workbench for Jupyter. We use Cloud Composer, which is Apache Airflow wrapped by Google into their semi-managed service. And Dataprog provides us main computing power for majority of data tasks. So even we are going to the cloud, from first sight, you hear cloud, so you think there is no infrastructure or is serverless, and you don't need to care. But unfortunately, we struggle with some infrastructure maybe not problems, but challenges. In current world or in old world on-premise, Hadoop cluster is centralized. It's one cluster for every user from the company. But going to the cloud, we we gave more power, more flexibility to the users, but all with such greater power, also they got greater responsibility. So in old words, analytics and data scientists, they only needed to write the workflow into Airflow DAG and write the Spark job. But in the new world of the cloud, they also need to care about the infrastructure. So we wanted to provide them very simple platform for that. And for them, it needs to be simple. But for us as data engineers, it's not so. Our company has a private IP only policy, which introduced much more configuration parameters to the cloud units. We also need a hybrid approach. So our GCP projects are connected to the on-premise data centers, which brought us another configurations factor and another limitations. So having that in mind, we couldn't give to the data to tell that to data science people, because it would be too much for them. So we chose Cloud Composer as a greatest guy we had to struggle with, but fortunately we wrestled it to the ground. Okay, so we started from sandboxing. There was not any platform for infrastructure, and let's try to bring to the life Composer with at least private IP only policy. So for gcloud CLI, there are 4 more additional parameters. But in the console, it's awesome console, but some flags needs to be checked, some flags needs to be unchecked, and it wasn't so simple. Maybe when you do it hundreds of times, it is okay because you do it mechanically. But if you want to create it once and forget about that situation, it's not so easy. When we connected hybrid approach, it was like a big blast. Not only parameters for private IPs, but also parameters for hybrid connectivity. Our structure in GCP is divided into projects, and we wanted to connect each project to the data center. We had to provide individual network configuration for each project. So if our user wanted to create Composer with connectivity to data center, the user should check which address to use, which address to put in different places. So yeah, it was too much, and it wasn't very feasible. So we we decided that we will hide as much as possible for the end from the end users, but we had to provide some freedom for power users as data engineers. Also, we noticed that using this hybrid approach configuration, there can be some conflicts. And those conflicts means potential errors during creation of the infrastructure, and some timeouts were long. So we wanted to discover such configuration conflicts in front of infrastructure creation. So we created simple abstraction for infrastructure creation. And from the beginning, we wanted to have it ready for multi-cloud. So now you can see 4 lines of code, which gives you a Cloud Composer. But under the hood, the Terraform is a foundation of our infrastructure creation process. But from the end user perspective, it is just a simple meta language. In this situation, it's YAML. When you put that into your project, it is such example. It is also in the template of the infrastructure service. So you just need to uncomment those lines, and you get default Cloud Composer for 99% of Allegro's data use cases. So this Terraform is created during translation process. So our library for translating this YAML to Terraform checks the network configuration for the desired project and put everything to that Terraform. It is also possible to parameterize that stuff. You don't need to create only default composers. So there are a bunch of variables in the Terraform, and you have to add parameters to the DSL with the same name as variable in the Terraform module. So in that situation, there's some problem, but I hope you can see. In this example, we put more nodes to the cluster and changed machine type to the bigger one and put more storage. Yeah, but when developers saw how awesome is a tool for data scientists, they also wanted to have such simple stuff, but in pure Terraform. So what we have done, we just put that logic which fetch the configuration from somewhere. We put that logic into the Terraform module. So it is also super simple for data engineers. it is so simple as DSL, but all the magic is behind that Terraform module. So eventually, we also took that logic from DSL translator to the Terraform. But how it goes? We have infrastructure translator library, which it depends on if you choose pure Terraform mode or DSL. It translates YAML to Terraform, but if you choose Terraform, it just takes all your Terraform code, archive it, and uploads to the Artifactory. That code is a part of. It is in the repository. It is a part of infrastructure service. So when you make a change, CI process starts and it builds that artifact. Artifacts are stored in the Artifactory, so you have all the version control. You can go back or whatsoever. Yeah. So code is ready. So let's create something. We don't support local deployments of the Terraform. All runs are from Kubernetes cluster as a deployment job, and the environment from that deployment job is closed in Docker image, which contains all the libraries and binaries for the Terraform. Also, individual service account for authentication and authorization with the cloud provider is prepared for each service. So you created your service from our application engine in Allegro, and you then trigger the deployment from there. You can choose whether you want to deploy branch snapshot version to check what will happen, and after you click deploy button, first Terraform plan runs. You read it, check what is the change, and it is a great benefit from that journey, because we taught our data scientists how to read Terraform plan output. So we haven't yet taught him how to write Terraform, but at least they can read the output from that system. So let's summarize it a bit, because time is ticking. If you want to create any infrastructure for big data calculation, new service in App Console needs to be created. We provide a set of templates. So the first one is the most generic. It provides you just infrastructure, but also this infrastructure template is a subset of PySpark and Scala job templates. So you also can have the infrastructure part of your data job project. you choose from pure Terraform or such simplified domain-specific language. All Allegro-specific parameters are hidden in those default templates, and as a final effect, we get Terraform code which is immutable and versioned in the Artifactory. So that was quick quick story about dot problems. More about Allegro. You will get the presentation. You can check, but please be welcome to the Allegro Tech meeting, because last year we opened our internal technology conference to the public. Probably in this year there will be another edition, but there is a great archive of the presentations from last year. Okay, thank you very much. We still have some time for questions.